Okay, the next function we're going to look at is the hyperbola or hyperbolic function. The textbook likes to call these reciprocal graphs. Okay, they are of the form y equals a over x. If a is positive, then the hyperbolic function will lie in quadrants 1 and 3. The hyperbola is a function that exists in two quadrants, two of the four quadrants. So if a is positive, the function will lie in quadrants 1 and 3, and if a is negative, the function lies in quadrants 2 and 4. So we have two hyperbolae here. The first one, this function is y equals 2 over x. A equals 2, which is clearly greater than 0. So the function lies in quadrant 1 and 3. And this function over here is y equals minus 2 over x. A equals minus 2, which is clearly less than 0. The function lies in quadrants 2 and 4. So that's the general shape of the function y equals a over x. Now, to sketch these functions, we use a table of values, much like we did with the linear and the quadratic function. So we're going to draw up a table of values. We're going to select 5 x values, and then we're going to plug them into the function and determine the corresponding y values. Now, one thing to note about the hyperbolic function is that we have what are called asymptotes. An asymptote is a line that a function will never cross. So if you look at these, if you look at the first function, y equals 2 over x, this arrowhead moves up to positive infinity along the y-axis, and this one moves horizontally very close to the x-axis, but the graph will never cut the y-axis or the x-axis. So the y-axis and the x-axis are, for this function, the asymptotes of the function. Exercise 16c. Copy and complete the table below to draw the graph of y equals 2 over x, for x is a value between minus 4 and 4. Okay, so we start off at 0.2. These are the values that have been selected for x: 0.2, 0.4, 0.5, 0.8, etc. So to find the corresponding y value, we're just going to substitute each x value into y equals 2 over x. You can use your calculator for this and write down the corresponding y values. Okay, so use your graph to find the y value when x is 2.5. X is 2.5, 5 over 2. So you can clearly see that in this table we don't have x equals 2.5. That's what we're using the graph for. So we're going to go to 2.5 on the x-axis. So 2.5 on the x-axis is here. We then move up to the function, which is there, and it's just below 1. It's just below 1. So we're going to approximate a value. Depending on the graph that you have drawn, you're probably going to have grid paper, block paper with more divisions than what has been shown here. So it'll be easy for you to read off the value. Y equals 2 over x. What the y value you should get, if x is 2.5, then y will be 2 over 2.5, 4/5 or 0.8. So this value over here is going to be 0.8, which we could see is just below 1. Use your graph to solve the equation 2 over x equals 7. So 2 over x equals 7. 2 over x represents y. So this over here is y. We're essentially saying what is the value of x when y equals 7. So we're going to find y equals 7, which is over there. Move across to the graph, which is at this point here. And then we're going to drop a perpendicular down. And we're going to estimate. We have to estimate here because we don't have precise values. But if you want to know what that value is, 2 over x equals 7. So x equals 2 over 7 which is approximately 0.29, right? Which this mark over here is 0.5, and that's, yeah, very close to that. So again, depending on the grid paper that the block paper that you're using, you'll be able to pick up a more accurate value than what has been shown on the diagram, on the graph, but you can obviously use algebra to know. You can use the equation of the function to determine the actual value. Use your graph to solve the equation 2 over x equals minus 1.25. This 2 over x again represents y, so essentially we're saying find x when y is minus 1.25. Y equals minus 1.25. That's minus 1. Minus 1.5 is between minus 1 and minus 2. And halfway between that would be minus 1.25. So minus 1.25. So it's about there. We turn from minus 1.25 on the y-axis to the function, and then plot the perpendicular up to the x-axis and read off the value over there. Now we don't have the divisions here, and we can need a more accurate grid to read off the exact y value of minus 1.25 and the exact x value, but you can work it out algebraically. When y is minus 1.25, we'll have 2 over x equals minus 1.25. X is 2 over minus 1.25. X equals minus 1.6. So you can see it's just about at the minus 1.5 mark, but that's because we don't have accurate grid paper. And we need to mark off minus 1.25 on the y-axis accurately in order to get the accurate answer for x. Complete the table to draw the graph of y equals 5 over x for x is a value between minus 20 and 20. Okay, so again, we just take all these x values that they've listed for us, and we substitute them into the function and get the corresponding y value. So on the same set of axes, draw the line y equals x plus 10. Y equals x plus 10. Okay, so this is a straight line graph. The easiest thing to do is to just plot the x-intercept and the y-intercept, and then just put a straight line through those 2 points. So the x-intercept, y equals 0. So when y is 0, we'll have 0 equals x plus 10. So x is minus 10. So the x-intercept is minus 10, 0, which is there. Call that point A. The y-intercept will be when x equals 0. So y equals 0 plus 10. Y equals 10. 0, 10. The point B, 0, 10 is the y-intercept. So we plot 0, 10, and we put a straight line through those points. Use your graph to solve the equation 5 over x equals x plus 10. So we want to solve 5 over x equals x plus 10. Okay, if we just look at these functions now, it's a nice notation to use f of x and g of x and h of x to label functions. It's just easier to work with. So if we call y equals 5 over x, if we just call this f of x, it's just a label, it's just a name for the function, and y equals x plus 10 as g of x equals x plus 10, then if we just look at what we're required to do here, 5 over x equals x plus 10, they're basically saying 5 over x, which is f of x, must equal x plus 10, which is g of x. So what that means, because f of x and y and g of x are y values, where are the two functions equal to each other? So where do the two functions intersect? All right, and we can't see it very clearly here, but this goes up and it intersects at about there at P, and the two graphs intersect here. A is this point here, the x-intercept, but where the two functions intersect is where I'm marking now, over there. So we need to estimate that. So we have to just estimate what the x value is. So it isn't very clear here That's minus 12, that's minus 10. It looks like it's about minus 10 and a half. So x looks like it's about minus 10.5, and y is there, just about there. That's minus 1. It looks like y is about minus 0.5 or minus a half. And then you'd estimate p as well. So this would be q. And then you'd estimate, depending on how accurately you've drawn your graph, you'd estimate the x coordinate of p and the y coordinate of p.